In the continuing Copernican revolution, the discovery of other universes and life beyond Earth might be the final frontiers in showing that we're not special. Speculation about life in the universe goes back to the ancient Greeks, who also speculated about the nature of the universe itself. We can see different viewpoints from the writings of Epicurus and Aristotle. Epicurus, in his letter to Herodotus, said, "There is an infinite number of worlds similar to ours and an infinite number of different worlds. One must agree that in these worlds, without exception, there are animals, plants, and all the living things we observe." To him, it was unexceptional that if there were many worlds in space, they should be inhabited. Aristotle, by contrast, thought the Earth was special, thought that humans had primacy in the cosmos and were unique. In those days, there was no way to decide between these two positions. We may, however, be on the verge of being able to decide by experimental observation in space. In advance of detecting life beyond Earth, the expectation amongst most astronomers that it does exist is based on a convergence of arguments. These are just plausibility arguments. They certainly don't amount to a proof. They include the fact that organic material and the basis of life's chemistry can form naturally on Earth, and some level of biochemical complexity builds up automatically and without intervention. Life also appeared early in the history of the Earth when conditions were extremely inhospitable by present-day standards, leading to some indication that life will happen when it possibly can. We also know that life can survive an extraordinary range of conditions on the present-day Earth. Finally, we know both that the chemical ingredients for life are widely dispersed through the cosmos, and that habitable sites for life, in the form of planets, are abundant, because essentially every star is likely to have at least one terrestrial planet. The goal here, which may be achieved by the planet hunters in the next decade, is to find another pale blue dot. Carl Sagan used an extraordinary photograph from the Voyager spacecraft in the 1970s to spot the Earth backlit by the gossamer thin rings of Saturn. He nicknamed this evocative image of the Earth the pale blue dot. To him, and to most of us, the Earth is a precious planet, but that doesn't mean that it's unique. We have a difficult job in imagining life beyond Earth. Terrestrial biology is based on an extremely successful theory of evolution based on natural selection, which works at the organism level, and an extremely successful molecular theory based on DNA and RNA. We have no idea if these are universal constructs, if either the organismal form of natural selection applies or the genetic code is universal. We are essentially trying to think beyond Darwin, out of the box, and what hypothetical biology might be elsewhere. This is an exercise that science often does, and it's quite useful. We can look at the universe the way it is, but sometimes it's informative and spurs our creative thinking to imagine things that could be, but aren't. These are called counterfactuals. Meanwhile, astrobiology is a young subject. Our ignorance far exceeds our knowledge. That ignorance starts on our own planet. Most of the biosphere is uncatalogued. Most microbial species have not yet been cultured in the lab or fully understood in a biochemical sense. We've just poked around the solar system, not even investigating all the possible habitable places with our probes and our telescopes. A tiny fraction of the projected number of habitable moons and planets has been identified, and even fewer have been characterized. And finally, in the search for extraterrestrial intelligence, a tiny fraction of the cosmic haystack of parameter space where signals might exist has been searched. Thinking outside the box in science is what makes science fun. We can imagine that in the universe there are things that are and things that aren't, things that happen and things that don't happen. There are also a large number of things that are possible, that don't violate any law of physics, that may, in practical terms, not happen at all. The compounding effect of all this is our imaginations, because we're clearly capable of imagining all the things that do happen, but also some things that don't happen. And without a general theory of biology, applying this to life beyond Earth is quite difficult. For example, we might imagine that life does or doesn't need planets. We might imagine that life uses DNA as its genetic material, but it need not. We might imagine that life doesn't need a star. We, of course, might imagine that life is structurally and morphologically unrecognizable to us, in which case detecting it will be extremely difficult. The expectation that life exists beyond the Earth in advance of its discovery is based on the abundance of chemical ingredients for life in the cosmos and of habitable sites, on the fact that life started very early in the history of the Earth and has radiated into almost unimaginable physical conditions, and the fact that in laboratory conditions we can watch simple chemicals increase in their complexity, though not to the level of a replicating molecule.